EVAGUIDE is a system that helps manage crowds in large venues like a stadium. It does so by guiding crowds using dynamic signs, mobile apps, and information given to stewards to direct spectators. But to be able to guide the crowds, the system needs to be capable of determining what the best routes actually are. An evacuation will most likely be caused by an incident or threat somewhere in or near the stadium. This inevitably means that some routes that might normally be used by spectators are now too dangerous, and spectators need to be guided along other routes. The EVAGUIDE system has an intelligent component that simulates how crowds will move during an evacuation. At its core is a model of crowd behavior and motion that can predict the likely movements of spectators in any situation. It predicts the time it will take to evacuate and the congestion that will be seen on all routes throughout the evacuation. The control room of the stadium can see this information and make better decisions based on it. If they know that some areas are going to be more crowded than others at a specified time in the future, they could make operational decisions to mitigate that risk. The crowd models that have been developed are also capable of optimizing which routes crowds should take, so that the time to evacuate can be shortened and congestion along evacuation routes can be minimized. This is how EVAGUIDE chooses evacuation routes to avoid areas that are too risky and prevent crowd safety problems that would otherwise be caused by redirecting crowds. The crowd model is given live data that's been gathered by other EVAGUIDE components or stadium systems, which means it knows where every spectator is in the stadium and which routes are going to be blocked because they're too dangerous. It processes this information and makes all predictions of crowd movement and route optimizations in a matter of seconds. This provides an instant picture of what is happening now and in the future, along with where to move everyone in the stadium during the evacuation. This can be then communicated to the crowds through the signs, apps, and stewards. Whilst these calculations happen automatically based on the current data and keep updating as the evacuation progresses, the control room always makes the decisions on how to evacuate. They can provide additional information, such as routes that are blocked for a reason that the system can't detect. They could choose a partial evacuation, selecting only certain stands or areas of the stadium that are at the most risk and evacuate those first. They can choose to send spectators to the pitch rather than outside the stadium. The crowd model will combine all of this information and predict the crowd movements for all of these scenarios. By doing this, there's a much better situational awareness than what currently exists, with not only what's happening now, but also what will happen if certain decisions are taken. By optimizing and communicating the best routes for spectators to take, the crowd models calculate things that humans can't process quick enough during an evacuation. It is telling the control room what is best based on scientific principles and based on actual data from within the stadium.